Hi, everyone. Welcome to class. So I plan to cover decision rules after decision trees. So the reason you see module 6 after, I think, module 2 in your E-class is because I decided to cover association rules first. And this is because your assignment 2 is about this association rules. So just giving you enough time to work on this assignment. And this is one of the most important topics in data mining. And I personally love this topic. And this is because you will realize when we are talking about different concepts here, you can immediately relate it to many real-world applications that you use like in your daily basis. So here is the outline of the whole module and basic concepts of association rule mining, Apriori algorithm, and FP growth. So I'm going to cover these two algorithms probably next session. The whole module will be covered, I think, in 3 sessions. And first session, which is today, covering basic concepts. And next session, a priori, maybe FP growth, and then pruning. So let's start with the main objective or the big question. Why do we even mine association rules? So let me give you first an example of association rules. Association rules are what you see in your daily life. For example, in the e-commerce applications that you're using, you see that people, for example, you get some recommendations like, if you, for example, buy this, you may also want to buy that. Or these are the items frequently purchased together. You can see it on Amazon, not only like in these kind of like applications, Netflix, even social media platforms. So there are many applications of association rules. So given that, why do we even need association rules? You can think of its applications.
Recommend items that are frequently bought together.
One, yeah, as I said, one advantage is you can increase, like from a business perspective, you can increase sales, right? You can recommend other products that are relevant or the items that are purchased together. You can use in bundle promotions. For example, you can package items together, applying discount on them. You can use them in cross-selling, right? If you buy this, you may want to buy that. If you buy iPad, you may want to also use pen. You may want to, for example, if you buy a laptop, you may want to buy the cover for your laptop, and so on, right? So you can increase your sales for other items that are related. And there are many other applications and advantages. These are just some examples. And here you can see another example. For instance, given a database of transactions, and each transaction includes list of items. So you may find that customers, for example, buying computer, tend to also buy a financial software. And we always, for any rule, we have support and confidence. What do they mean? Like in general, support means frequency. And that is frequency of items appearing together. So if I write, for example, X implies Y, and X and Y are, let's say, items. So, and I say, let's consider X as, I don't know, bread, Y as butter. And then I say, X implies Y, like, for example, right? Where X and Y belongs to our whole item set, right? Now, let's say X is, I don't know, bread, Y is butter. This is an example of association rule, very simple one. And I can tell you this with support of, I don't know, 20% and confidence of 80%. Now, what does this mean? So in general, support measure frequency, which means there is 20% chance that bread and butter, not chance actually, this is the actually like out of all the transactions, 20% of all transactions include both bread and butter, okay? So this means, for example, for X implies Y, it means the percentage of times or percentage of transactions where X and Y were purchased or appeared together. And what does confidence say? Confidence is the reliability of this rule. So, okay, we know that, for example, 20% of transactions include bread and butter together, but confidence means among all transactions including bread, including X, what percentage also include Y? And why is this important? Again, for example, in recommendation, you can predict users' next purchase or suggest them, right? You can suggest, for example, covers or cases after, for example, buying computers. You can recommend butter after buying bread because in 80% of transactions that include bread, butter also exists. Now, I'm going to explain about support and confidence more. This is just some examples and introduction. Next one, in a student database. Example from a student database. For example, students majored in, X refers to a specific student, majored in computer science and have, for example, GPA A, tend to take, for example, database course. Now, one important thing here is that we do not infer any causal effect here. So it's just a pattern discovery, okay? So we do not imply the causation here. We just mean that there is this pattern. And so if, for example, and let's say the support is 1% and confidence is 75%, what does this mean? That is only in 1% of all the records that you have in your database, only in 1%, you can see students from computer science with GPA A who also take database course. So this combination, so here your X is here, right? And this is your Y. So like all these items appearing together. So the item shouldn't necessarily be like product in e-commerce context, right? Could be anything. Now, what does the confidence of 70% tell you here? It says that out of all those records where students have, for example, are from computer science major and have GPA A, 75% of those students, 75% of CS students with GPA A have taken database course. And this is a very important concept. We will see why. So one of the most famous applications of association rules is in market basket analysis used by many like giant e-commerce applications. And so, for example, if you see that items are frequently bought together, as I mentioned before, what, like from a business perspective, how it can affect your decision. Okay, someone says, so what? Okay, these appear together. It matters a lot, right? Because then you can promote those items together. You can increase your purchase through them. As I said, you can use them in bundled promotions, you can use them in cross-selling, and many more. So you can, like, even in a physical store, you can put them like next to each other. So you can put, for example, I don't know, milk and butter next to each other if they are frequently bought together. And so that's why, for example, if you go to grocery store, let's say you want to search for baking products, right? So you often find them next to each other. You don't go, for example, finding baking powder in one aisle and then finding other related products somewhere else. And just to increase their visibility, right? And you can use them also on promotions, cross-selling, and so on. Then we have, so if we have frequent item sets, and I'm going to explain about frequent item sets later and how we find them. But let's say if bread and butter, let's say if this, or in general, X and Y, so this is a frequent item set, which means these 2 items, or how many items, it could include 3 items, 4 items, or even 1 item. It means that this item or these items are frequent. Now, we later see that we may want to set a threshold to identify what we want to consider as a frequent, right? Because it's not unique. It could change. So let's say bread and butter is frequent. So they frequently appear together. So you can write 2 rules. So you can infer 2 rules from this. One is bread implies butter. The other is butter implies bread. Now, for each of these rules, we have to find support and confidence in order to identify whether this is a strong rule. That means whether it is an interesting rule or not. We may infer lots of rules from our item sets. Not all of them are interesting. And we'll see which ones are interesting later. So now what I want you to know at this point is that if this is a frequent item set, these are the 2 rules that you can write. Now with, of course, support and confidence, right? You have to also specify their support and confidence. Now I have a question. Do they have the same support? Do they have the same support value? Does X implies Y has the same support value as Y implies X?
Logically not.
What is Y?
Logically not.
Yeah, so what is the logic behind it?
So the logic behind it, so negative Y will imply X maybe. Yeah, like you cannot just flip them and assume that's the same.
X implies Y. When we talk about support, as I said, support means frequency of these 2 items appearing together. What percentage of times X and Y appears together? What does this one imply? What percentage of time Y appears together with X? Is there any difference? No.
The order.
In support, I asked, yeah, my question was, do they have the same support or the support are different? Always the same, because support measures the frequency of items appearing together, right? So support for bread and butter, right, for this rule means percentage of times in your transaction database. Let's say you have a transaction database here. Let's say you have a transaction database with transaction ID and then your item sets here. So you have transaction 1000 here, 1001, 1002, 1003, and so on. And then each transaction includes sets of items, right? For example, it may have milk, bread, butter here. Then we may have only milk and chocolate here. We may have bread, butter, and salad maybe. And then we may have, again, bread and chocolate. Okay, so we may find that bread and butter frequently appear together. And it depends on what threshold we define for our support. If I set the threshold to 50%, it means all like item sets that appear that their support is like equal or greater than 50% are considered as frequent item sets, right? So in this case, let's say the threshold is 50%, then bread and butter are frequent item sets. And I can infer these two rules from that. So each of them is a separate association rule. In terms of support, they have the same support because this rule, this means the frequency of the percentage of times in your transactions where you see bread and butter together. Here, it's the same thing. Percentage of times where you see butter and bread together. So in both cases, it's 50%, 2 out of 4 transactions, right? So support for both of them is the same. How about the confidence? Is their confidence also the same? Why?
Those 50% transactions where bread and butter appear together. Out those 50% of transactions, the number of transactions where butter appear with bread is different.
Yeah. So what is confidence? When we have X implies Y, support means percentage of times where you see X and Y appearing together. Their co-occurrence, right? Or frequency, measuring frequency. But confidence is reliability of that rule. It means it's a conditional probability. It's like, for example, what is the probability of X happening given that, for example, we have Y, right? Now, here, when we have bread and butter, it's like out of all transactions including bread, what percentage of them include butter, right? So how many transactions include bread? 1, 2, 3, right? So confidence is out of 3 transactions that include bread, how many of them also include butter? So now I do not consider this transaction at all because it doesn't have bread, right? So now out of like these 3 transactions including bread, how many of them have butter? 2 out of 3, right? Now, I don't know, this is around 70%, 66, something. What about this one? What is the confidence for this rule? It means out of all transactions including butter, what percentage includes bread? So these are basically different because the number of transactions where including bread is not the same as number of transactions including butter, right? Now, number of transactions including butter is this transaction and this one, 2 transactions, right? Out of these 2 transactions including butter, what percentage have also bread? So let's see. This one has butter, has also bread. This one has butter, has also bread. So it's 100%. So their confidence can be different. And now you see these, like, we can think about these questions to better understand what do we mean by association rules. So in this example, we want to see which items frequently co-occurred with iPads, or in other words, what items tend to appear before or together with an iPad. Now you may find out, for example, a stylus pen is often bought, for example, before or together with the iPad, right? And with some support and confidence numbers, of course. And you can use that to increase sales of iPad, right? And how can you do it? You can, for example, put these stylus pen next to, for example, next to iPads, right? To get the attraction of customers. You can like indirectly increase your sales, right? Now, what about this one? iPad. If you buy iPad, then what would be the item that you're going to buy next?
Case for your iPad?
Anything, right? So the meaning of the question, right? The meaning is, for example, what other products should the store pick up, right? So items that commonly bought after buying iPad. So it's like, for example, if you buy, for example, I don't know, if you buy milk, then you may also buy biscuits, right? Or cereal, something like that. And their support and confidence, while their support are the same, their confidence may not be the same as you've seen in this example. So what kind of database? So far, we've included transaction databases. So this is the most common one especially for market basket analysis. We use transaction databases. This includes only transaction ID and item sets, and in some cases, we can consider it as just set of different item sets. And so what is an item set? Just a set of items, right? For example, in this example here, what is your item set? F, A, C, D, G. So all like distinct values that you have as items in your table. So in the example here, it is more clear. What is the item set here? So your whole item set include milk, bread, butter, chocolate, right? Salad. So all the items that exist in your database. Now each row here representing a transaction. So this is a tuple including transaction ID and an item set. And the transactional database is just set of like these transactions as you see here. So now keep this table in mind and see the ones marked in green here, like the items marked in green. So these are your frequent items. So let's say we have this rule, association rule from the previous transaction database. And we write if someone, for example, purchased A, C, and M, it implies that it may also be interested in L, in item L. And with what support and confidence do we say this? We want to see how strong this rule is. I'm going to talk about strong rules more later. But for now, it just means that what is the support and confidence here? So support is 40%, confidence is 66.7%. What does it mean? In this case, in the context of this example, what does this support and confidence represent? Sorry?
Support is maybe like the amount of times the items appear together.
Support percentage of transactions including A, C, M, and L together. So all transactions on both sides of your rule, right? And then what about confidence? So what does confidence of 66% implies here? Let's go back here to see.
66% of those 40% transactions will have all four items.
No, sorry, but no. Yeah.
So the 40% meaning, not all transactions, 40% has all four items, right?
So for support means frequency of all these items together. So as you said, so what you described is support, right? So you both correctly described support, which means 40% of transactions, 40% of all transactions include A, C, M, and L together, right? So this was the rule, right? A, C, M implies L, right? So when we say support is 40%, it means in 40% of transactions, you see A, C, M, L together. So let's check. Do we see A, C, M, L in the first one? No, we see it in the second transaction and also in the last transaction. So 2 out of 5 transactions. 2 out of 5 means 40%. Now, what is the confidence? Calculate the confidence. Confidence means out of transactions including ACM, what percentage include L? So we have to first see how many transactions include ACM, right? First transaction, second transaction, last transaction, right? So 3 transactions out of 5 transactions, right, include that. So out of these 3 transactions, so we don't care about the other 2, right? We only care about these 3 because we want to see how reliable is this rule, right? That is what confidence is. So out of these 3 transactions, including these, how many of them also include L? So the first one doesn't have, second one have, last one has it also too. So 2/3, which is 66.6%. And so this is basically what is explained here. So support of 40% means proportion of transactions that contain all these items together. And confidence means conditional probability, which means considering the number of times or number of transactions where A and C and M appears. Now, what percentage of them includes also item L? And that gives you 66.7%. So what kind of database, apart from transactional database, which we provided some examples, we may also have relational databases. So not always we are dealing with transactional databases. For example, the example I provided in previous slide about students who major in computer science and GPA, for example, A, tend to take the course, for example, database, is not a transaction database. It may be, for example, in a relational database. So relational databases are represented in tables with rows and columns, where columns representing attributes or fields, right? And then each row or tuple representing, for example, sets of those attribute value pairs. So providing values for each field, right? For example, this is an example of attribute value pair. For example, outlook sunny, or humidity high, or wind, for example, strong, right? So these are examples of attribute value pair. What could be an example of association rule here? For instance, if outlook is sunny and temperature is hot, it implies that play tennis decision is no, so we don't go to play tennis. Now, what is the support and confidence of this rule? So in order to find out support, you have to see how many times, what is the percentage of times that outlook sunny, temperature hot, and play tennis no appears together. So out of 14 days, how many days have all these three? So for example, the first one have outlook sunny, temperature hot. The second one has outlook sunny, temperature hot, play tennis no. Do we have other cases? Outlook sunny, temperature mild, temperature cool, mild. So there are only 2 transactions out of 14 transactions, right? Where outlook is sunny, temperature is hot, and play tennis is no. So that means 2 out of 14, right? Which is 14% of transaction. Now, with what confidence do we say that? That means what is the reliability of our rule? What is the confidence of our rule? And then that means out of all those rows or records where outlook is sunny and temperature is hot, which is only the first and second day, the first 2 rows, how many of them also have playing tennis? No, all of them, 2 out of 2, which is 100%. And that's why confidence is 100%. And here we just want to see everything mathematically. So whatever we discussed so far, we want to see it mathematically. So an association rule is of this form: X implies Y or X then Y, with, of course, some support and confidence values, right? Now, where X is a subset of I, so I is your whole, like the item set, and X and Y should be the subsets of I, of course. And also, X and Y should not overlap, so they should be disjoint. Why is that? Why they cannot overlap? Because then it's like you say X implies X, right? It doesn't make sense. So, and if you want to just formalize mathematically like these 2 support and confidence measures, support is the probability that a transaction contains X and Y, both of them. So you're both antecedent and consequent. So the left side of your association rule is called antecedent, and the right side of your association rule is called consequent. So support of X implies Y is the probability of X and Y appearing together, right? Which means the probability of X union Y, right? That's the meaning of the union mathematically. And confidence is conditional probability that a transaction that have X would also include Y. So this is, again, the definition of conditional probability, right? Because it means given, for example, X, what is the probability of Y? Given, for example, bread, what is the probability of seeing also butter? And so this will be probability of y given x, right? Or the conditional probability. And we can also say this also mathematically is equal to support, right, of x and y divided by the, because it's the union of x and y divided by the probability of x. So we can see more examples. So let's assume we are analyzing market basket analysis. So this is similar to the example I provided here with more items. Now we have 6 transactions here, and these are the items in each transaction. So what is your item set here? What is your item set?
Butter, milk, cheese.
Yeah, all the distinct items. So bread, milk, egg, butter, cheese, coffee, cereal. So what are the frequent items? In order to find the frequent item sets, you have to find all frequent items of size 1, size 2, size 3, and so on. So for example, all one item sets first. By one item set, I mean, for example, this: milk, chocolate, coffee, and so on for all items. And then the 2 item sets, for example, milk and chocolate. And you have to consider all combinations, milk and butter, and so on. So it will be 2 to the power of n minus 1, right? Removing the empty subset. Then you would have all these numbers, which can be huge for a large data set. But here, just looking at the data, let's say we have, for example, x, which is bread and butter, and we consider this as a frequent item set here. And we have y, which is milk and cheese. This is also, let's say, another frequent item set. Now, we write this association rule that bread and butter implies milk and cheese. So what does it mean? If someone is buying or purchased, for example, bread and butter, they tend to also buy milk and cheese. Now, what is the support and confidence for this rule? Let's see. Support means percentage of times all these items appearing together, which means percentage of times you see bread, butter, milk, cheese together. Out of 6 transactions, how many times you see all these 4 together? 2 out of 6 transactions, right? So you see bread, butter, milk, cheese in the first transactions. And again, you see it in the third transactions, right? So 2 out of 6, which is 33% of times. That's your support. What is the confidence? It's easy. Out of those 2 transactions, out of transactions including bread and butter, how many of them also include milk and cheese? So how many transactions include bread and butter? So first, second, third, fourth, and that's it. Yeah. So out of these 4 transactions,
12 over 3 or 12 over 4?
So first, as I said, confidence of this rule. Bread and butter implies milk and cheese. So bread and butter is your x. Milk and cheese is your y, right? And confidence means out of all the transactions including x, what percentage includes also y? So out of all transactions including bread and butter, which as you can see, out of 6 transactions, we have only 4 transactions including bread and butter. So out of these 4 transactions, what percentage of them also include milk and cheese? So the first one has, and the third one also has, right? So 2 out of 4. And so the confidence is 50%. So this is another example with a very small transactional database. So just to recall, support of x implies y is the probability of x union y. That is the probability that x and y appears together. And confidence of x implies y means conditional probability of y given x. Or what is the probability that you see y given that you have seen x? Or what is the probability that you purchase y given that you already purchased X. So looking at these, consider this rule, the first one. So we have these items, right? And let's say I write the rule A implies C. So A implies C. What is the support and what is the confidence here? Yep.
The support is 50%.
Why?
Because for two of it, so we have A, C, A, C twice over 4 transactions.
2 out of 4 transactions include both A and C, so support is 50%. And what is confidence? So confidence is 100%. Let's see. We have to see out of transactions, out of all transactions including A, what percentage includes C. So we have 3 transactions including A, right? Out of these 3 transactions, 2 of them include C. So 2 out of 3, which is about less than 70%, right? So we have support 50% and confidence 66.7%. What about C implies A? Support is the same. You don't have to calculate, right? It's the same support. What about confidence? Now you have to look for transactions including C and see what percentage of those transactions also include A. So which transactions include C? 2 transactions, first one and second one. Out of these 2 transactions, what percentage of them also include A? Both of them, right? So it's 100%. So like in this case, when you reverse a rule, the support doesn't change because it still includes the same items, right? But the confidence may change because the left side of your transaction is different, right? The probability of X given Y is not equal to probability of Y given X, right? Even mathematically, they are not the same thing. So for that reason, they may change. Now here, the third rule, A and C implies B. So what is the support? Support here is the percentage of transactions including A, C, B, right? 1 out of 4 transactions, which is 25%. So only transaction 1, right? Only the first transaction include A, C, and B, include all these 3 items. So this is 1 out of 4 or 25% of transactions. That means support is 25%. What is the confidence? 1 out of 2. So confidence is, let's see, confidence is for the third rule I'm talking. So out of all transactions including A and C, what percentage also include B? So out of transactions including A and C, which are only 2 transactions, how many of them also include B? Only the first one. So 1 out of 2 or 50% is the confidence. Now the last one. What is the support and confidence of the last one? 0 for both of them, right? Because no transaction includes all these items together. And so if support is 0, can I say confidence is also 0? If there is like 0% chance that A, B, and E appear together, how can I say out of like transactions including A and B, E also appeared, right? Again, it means that they should appear together. So that's why I said the conditional probability of P of Y given X means support divided the probability of X, right? P of X union Y divided to probability of X. That's why. So again, if support is 0, means confidence is also 0. And
I have a question.
yeah.
So the probability there, like how do you usually, like I see like the way you calculate the probability kind of, it depends on the example given, right? So is there a mathematical way of doing that? Or just like always going to be looking at the number of...
How to finding probabilities?
Yes, from this.
The way that I did, for example, what is the probability of...
Yeah, exactly. Like right
Yeah.
now we're looking at it by eye, right? But
Yeah.
if we have a mathematical way of calculating it for, let's say, if I have a huge set of...
Okay, I get it. So you mean your question is not about the probabilities, but about finding frequent item sets, right? In a large data set. How can we find frequent item sets in a very... So that's I'm going to explain later and why we need the a priori algorithm, FP growth algorithm, right? So we cannot do it like ourselves, just checking the database and say, okay, these are frequent. So that is the part that is computationally expensive and is done by these algorithms that I'm going to explain later. But for now, we have to first understand the basic concepts of support, confidence, rules, and which rules are considered strong. And then we explain these algorithms as well. So iClicker question 1. Let me open iClicker. Should be able to see it now. So for more people. Okay, let's see the results. 90% chose the correct answer, which is option C. Only 10% chose option B. So let me explain. And so the question says, suppose we have the rule X implies Y. If the confidence is 90%, what does that mean? So as I said, confidence means conditional probability, means the reliability of your association rule, which means considering X happened or purchased, what is the probability of Y? Or what is the probability of Y given X? So if confidence is 90%, it means out of all transactions including X, 90% of them also include Y. So option A says 90% of all transactions contain both X and Y. So this is the definition of support. This is, if support is 90%, yes, option A is correct. Option B says 90% of transactions containing Y also contain X. That is exactly the opposite, right? So we say X implies Y, so conditional probability here or confidence of this rule means given X, that is out of all transactions including X, 90% includes Y, right? So 90% of transactions containing X also contain Y. And as I said, we do not claim any causation here. These are just pattern discovery, okay? We just say, okay, people who bought X tend to buy Y, but we don't say they are like really correlated. And next. So if you want to define the problem, so the problem statement is this. Now, given a minimum support, or let's define a threshold for your support, and minimum confidence, which is your confidence threshold, find all association rules that satisfy both minimum support and minimum confidence. And this is very helpful for identifying which rules are interesting or which rules are actually strong, because we may infer many rules from our data and transactions. We may have many frequent item sets. Not all of them are strong. Not all the rules are important. Many of those rules may be infrequent. That means may have a small support. Many of them may have low confidence, which means they are not reliable enough, right? So we are looking for those rules that are frequent enough and reliable enough, okay? What does that mean? Frequent enough means they should meet the minimum support threshold, and confidence enough or reliable enough, reliable enough means they should meet the minimum confidence threshold. Because otherwise, how can you identify what is, for example, even considered as frequent item set, or which rule is strong or not? It really depends. And I'm going to show you with examples. Before that, before I even show you the algorithm, let's see some terminologies here. So a strong rule, as I said, is a rule that meets both conditions. That is, both frequent enough, and also reliable enough. That should meet these two thresholds. K-item set is an item set containing k-items, which is, for example, milk, bread, butter, including 3 items. So is a 3-item set. This is, for example, 1-item set. This is 2-item set, right? And this is an example of 3-item set. And then support count of an item set in data set is number of transactions that contain the item set. So be careful, this is different with the support percentage that we mentioned, right? So this is just support count of item set. And so this is just the number of transactions in the data set that contain that item set. Then we have minimum support count, which is your support threshold multiplied by total number of transactions. You better understand this with an example in the next page. And then frequent item set in a data set or item set whose support count meets the minimum support threshold. So let's see an example. For instance, let's say we have a data set with 1,000 transactions. And we know that the minimum support or support threshold is at 5%. So whenever, and this is what is given in the exam, okay? So for example, in any problem, you must know, of course, what is the support and confidence threshold. So if I tell you the support threshold is 5%, what does that mean in a database including 1,000 transactions? So what item sets can be considered frequent item set?
Anything that has that threshold. Right?
Which is
the appearance of these sets that more frequent than the threshold itself.
Yeah, so any like item sets that appear, that meet the minimum support threshold. So the minimum support threshold is at 5%. 5% in a database, transaction database including 1,000 transactions means 50 of those transactions, right? So if we have item sets that appear in at least 50 out of 1,000 transactions, that is, appear in at least 5% of transactions, right? Then that is considered as a frequent item set. Is that correct? Yeah. So that's why minimum support count is 5%, which is, as you see here, that's the meaning of this formula, right? Minimum support count is the minimum support threshold, right? Multiplied by total number of transactions, because 5% in a data set with 1,000 transactions is different with 5% in a data set including 1 million transactions, right? So if you're talking about, for example, a data set with only 10 transactions, then 5% means how many transactions?
50,000.
5% in a transaction with 10 transactions. So you have 10 transactions. So it's 5% of 10 transactions, right? Is that correct? So, yeah. So we say we have a data set including 1,000 transactions, right? And I say the support threshold is 5%, which means any item set appearing at least in 5% of transactions, right, it is frequent. So if the data set has 1,000 transactions and an item set appears in at least 5% of them, that is 5% of 1,000 transactions, right, which gives you 50 transactions. So if an item set appears in at least 50 transactions, considering this threshold, right, it means that it is frequent. So what I was saying is that that's why you multiply by this, because depending on the size of the data set, this number can change, right? So for example, if instead of 1,000 transactions, you have only 10 transactions, right, then this number is only this, right?
How can you have 0.5 transactions
Hmm?
How can you have 0.5 transactions? That's my question.
You cannot, so it should be another number. This is just an example, right? So for this, like a small transaction, this should be considered as 0, right? So you have to define like a higher threshold for that. Let's give it with another example. Let's say, for example, with 5% of, I don't know, database with 100 transactions, right? With 10 transactions, of course, 5% is nothing. So in this case, if If a transaction appears only in 5 transactions out of 100 transactions, it is considered as frequent. And so it is also important what is the support threshold. So if your support threshold is 2% or 5% or 10%, right, then the result would be different. So the whole point is why you are seeing, for example, 5% multiplied by this for the minimum support count, right? So this means an item set must appear in at least 50 transactions to be considered as frequent in this data set, right? So this is iClicker question 2. Okay, let's see the results. So 70% chose the correct answer, and others chose option B and D. So the question says, suppose the rule X implies Y has support of 40% and confidence of 90%. Given that minimum support is 50%, that is your support threshold, and minimum confidence is 70%, that is your confidence threshold, what happens to this rule? So let's see, what does it mean? So what does support of 40% mean? 40% of times, right, X and Y appear together. So that's the support of 40%. And then confidence 90% means out of all transactions including X, 90% of them also included Y, right? Now, we want to see if this rule is strong or not. So 2 options, option A and B says it's strong. So let's see, what do we consider as a strong rule? A strong rule is a rule that meets both minimum confidence and minimum support threshold, right? As I said, a rule is strong, so you may infer many rules, you may generate many rules, right? But we are interested only in the rules that are strong. What does that mean? They should meet the minimum confidence threshold and they should meet the minimum support threshold, right? Because we want them to be frequent enough and we want them to be reliable enough. So we want to get rid of those rules that are either very rare or infrequent, they have very low support, or they have very low confidence, that are those rules that are not reliable enough. So infrequency and unreliability, those are the 2 main factors to get rid of or prune some of these rules. Now, option A says it's strong because confidence is high. No. As I said, a rule is strong if support and confidence both meet the minimum threshold. What is the threshold for support? 40%. Support threshold is 50%, but your support is 40%, right? Does it meet the minimum support threshold? No, it doesn't. So it is not as strong, which rules out option A and B. Now, among options C and D, so the rule is not as strong. We have to skip this rule or just ignore it, right? You must discard it because it fails supporting threshold. And the other option says it's discarded because it fails confidence threshold. So in this case, if you compare the value of support with support threshold and compare the value of confidence with the confidence threshold, which one is the problem here? Which one doesn't meet the requirement? Support, right? Support threshold is 50% and your support is 40%. So it doesn't meet the minimum. Now, if I change the threshold, so if I say, for example, minimum support is, let's say, 20%, then what option is correct? If minimum support is 20% and minimum confidence is 70%. Option A is strong, and not only because confidence is high, we actually should have a more complete answer in that case, but also because it meets the support threshold as well. And next, so let's see. So this is the whole process. First, we find all the frequent item sets. So as you saw here, I first selected the frequent item sets. After you found what are your frequent item sets, and this is the most computationally expensive part, because imagine, as your friend said, if you have a data set including thousands or millions of rows, right? Millions of, for example, transactions with many distinct items, that's not considered, for example, Amazon database. So it's impossible to manually find out frequent item sets. That's where Apriori, FV growth, and many other algorithms come in. And so let's assume that we found all frequent item sets. So this is the key step. Then we can generate association rules from that. But we do not keep all the rules. We only keep the rules that are strong enough. What does a strong means?
Threshold?
Meet both thresholds that are frequent enough and reliable enough. So we ignore the ones that are rare, that are infrequent, or they are not very reliable. So generating rules that meet the minimum confidence threshold. And for each, why did we only write minimum confidence threshold here? Because the items that are frequent, in frequent item sets, it means they already met the minimum support threshold, right? Support measures frequency. It's a measure of popularity, right? Is that right? Yes. So they already passed that filter, and so we only want to see which ones now meet the minimum confidence threshold. For each of them, we create potential rule by splitting the item set into antecedent and consequent, right? So for instance, if we have x and y, we can write x implies y and y implies x, right? And then for each of them, we find what is the support and confidence. Of course, support is the same because in both cases, they have, we are searching for transactions including both x and y, but confidence could be different. And we only keep the rules that meet the threshold values. So let's see some examples. How to mine association rules. Example, given minimum support is 50% and minimum confidence is 50%. And this is your original transactional database. So let's say you're given this database, including these items and these transactions. And let's say we find out that frequent item sets are A, B, C, A, and C. Why are these frequent item sets? How did we find them? Using support threshold, right? So minimum support is 50%, which means for an item set to be frequent, it should meet this minimum. That should appear in at least 50% of transactions. We have 4 transactions here, right? So if an item or item set appears in at least 2 transactions, right, then it means that it meets the minimum threshold. So this applies to A because it appears 3 out of 4 transactions or 75% of transactions. B appears 50% of transactions, right? First and last transaction. Item C appears 50%, right? 2 out of 4 transactions. A and B doesn't appear here because A and B only appears in 1 transaction out of 4 transactions, which means 25% of times, right? E and F doesn't appear here, again, for the same reason. What is the support for E and F? 25%, 1 out of 4 transactions, right? So the support is 25%. We didn't include this here because they didn't meet that minimum. Same things apply to any other combinations that you do not see here, including 1 item set of E, F, 2 item sets of E and F and B and F, A and B, and so on, and also 3 item sets. So they all didn't meet the minimum threshold. So we want to generate some rules. Now, when you want to, in order to create or generate your association rules, as I said, the first step is to create your frequent item set. So we do not care about other combinations here. We only look at the frequent item sets, right? Because what are strong rules? The ones that meet the minimum support threshold and minimum confidence threshold. Meeting minimum support threshold means they should appear in the frequent item set, right? Those are the ones that met that condition. So that's why you don't, for example, see A implies B here, right? So A implies B. We don't even consider this. Even if you do, it's just a waste of time because you know that this is not frequent item, right? It doesn't meet the support. What is the support of A implies B? Appearing A and B together. How many times A and B appear together? 1 out of 4 transactions, 25% of time, right? So we didn't include that rule. And another point is that we cannot, so the rule that we infer are from each transaction, item sets in the items in each transaction. So you don't write, for example, A to B, B to C, right? Now for A implies C, what is the support and confidence? So support we already calculated here. What is the confidence? Confidence is out of all transactions including A, which are 3 transactions, how many of them or what percentage of them also include C? 2 out of 3, right? Which is 66%. For C implies A, support is the same, confidence is 100%, because in all transactions where we had C, A also appeared. So C was only in 2 transactions, and in both transactions we had also A. This is another example. Back to our original example now. Assuming minimum support is 50%, minimum confidence is 70%. Now, what are the frequent items? So let's start with just the one item set. For example, milk only. Is milk a frequent item set here, given this support threshold? So you cannot identify a frequent item set without the threshold, right? So here, I tell you minimum support is 50%. Now, milk is appearing in the 1st, 3rd, 4th, and 5th transactions, so 4 out of 6 transactions. So 4 out of 6 is for milk, right? So that's the support value for milk, which is about 67%, right? 4 out of 6 to 2 over 3, which is 67%. Now, the same thing for other item sets. You have to do it for all 1 item sets, 2 item sets, 3 item sets, and so on. So we have, for example, for milk, 4 out of 6. For bread, if you check, these 3rd transactions so 5 out of 6 transactions also include bread, which means bread is also frequent. Milk and bread is also frequent because it meets the minimum support value, right? Now, if I tell you minimum support is 60%, what would be the frequent item sets here? If minimum support is 60%. Yeah? Yeah, milk, bread, butter, and bread and butter. So you will not see if minimum support is 60%, right? If this was 60%, then you wouldn't have this and this, right? So depending on the threshold, the frequent item set may change. Now, what if the minimum support is, I don't know, 20%? Does it change? If minimum support is 20%, what items may be added here? For example, let's see which items we didn't have. For instance, 20% means 1 out of 5 transactions, right? So let's do it even less. I tell you the minimum support is 10%, right? 1 out of 10 transactions. So in that case, for example, milk, bread, butter is also a frequent transaction because if it is appearing in 1 transaction, it's considered as frequent. And then now that we have frequent item sets, we can generate a strong rules. Out of those strong rules, we can find the most interesting or the strongest one, right? Milk implies bread. What is the support and confidence? Support we already know. Milk and bread have 50% support. What is the confidence? Out of all transactions including milk, what percentage include bread? So 1, 2, 3, 4 transactions include milk. Out of those 4 transactions, only transaction 1, 3, and 5. So 3 out of 4 has also bread, which means confidence is 75%. For milk implies butter, support is already calculated before. And confidence is again 70% because out of 4 transactions including milk, 3 of them also include butter. For bread implies butter, we have to see, so we know the values for the support already from here, right? Now we want to, let me also erase this. Now we want to calculate only the confidence. So confidence is 80%. This is the strongest one. And it's because out of all transactions, including bread, which is 5 transactions, I think 4 of them also have butter, right? And so it's 80%. And same thing for butter implies bread. So sometimes it may happen that if you reverse the rule, sometimes the confidence is also the same, which is the case here. So the strongest rule that we want to keep here are these 2 ones. So is this clear? Yeah? So now finally, as I said, in real world cases, so I'm just finishing this here, just 2 minutes. So in real world, we have data sets with millions of rows, like a large number of distinct item sets, and it's not possible to find out frequent item sets just manually, right? It's impractical. So we need some algorithm. And to clarify the difficulty of finding those item sets, considering a database with only 4 items, for example, A, B, C, D, if you only have only these 4 items, how many possible item sets exist? 2 to the power of 4, right? Minus 1, right? Now, this is, for example, equal to 15 in this case. Now, let's say n is, for example, 100. So if you have 100 items, that would be a very large number. If you have millions of items, then that would be even more. So we have a very important property called Apriori property that is a basis of Apriori algorithm that I'm going to explain next week, which says any non-empty subset of frequent item set must be frequent. And this is very important. What does it mean? It says if ABC is a frequent item set, all of its subset must be frequent. And it makes sense, right? If ABC appears, for example, let's say 100 times, and they are considered as frequent, so A and B, of course, appeared at least as many times as ABC, right? They may appear also more, but not less. But what is even more important is what we infer from this rule. So that is, if an item set is infrequent, then none of the superset is frequent. This is very helpful because it helps you reduce the search space dramatically. You can get rid of all the non-interesting ones. So if an item set is infrequent, for example, let's say A is infrequent. Can A and B be frequent? No. If A and B is infrequent, A, B, C cannot be frequent. So we see this here. So if C is infrequent, as you see, all of these cannot be frequent, right? Because any transaction containing C, right, must also, for example, A and C must also contain C. And so all the supersets of C cannot be frequent, and we can just prune them and reduce the search space a lot. This is your last question, and then you can go. Okay. Yeah, so most of you chose the correct answer. Only 6% chose option A. So suppose item set A and B is not frequent, what can we conclude? First option is not correct. If A and B is not frequent, we cannot infer that A is not frequent, right? Same thing here, B is not frequent. We may have A frequent, right? But for example, this combination may not be frequent. Any items containing A and B cannot be frequent, right? And then the last option says A, B, C may still be frequent. So this cannot, if A and B is not frequent, the supersets cannot be frequent as well, right? Because they have at least A and B in them. And that's it. Do you have any questions? No? Okay.